Hi, my name is Timothy Troop, and I'm System Architect with MultiTech Systems, and I'm delighted to be here today to talk to you about wireless sensors and incorporating them into building management systems. MultiTech manufactures a wide variety of wireless LoRaWAN sensors as well as LoRaWAN gateways that can be incorporated into a building management system via the BACnet protocol for additional monitoring, surveillance, and maintenance capabilities. So let's get started. What we're going to talk about today is how to integrate LoRaWAN with an existing building management system. So in the early days of building management, there really was no remote control. You have to adjust the thermostats, often by hand. There was no really remote control. So as the years went by, buildings became more sophisticated and building management systems became more sophisticated. Rather than going up to a room making adjustments, thermostats or temperature sensors were put in rooms, and some basic logic was developed that said if it fell outside a certain range of temperature or humidity, invoke something in the building management system to make adjustments. And that's kind of the way it's been for a long time. And that control mechanism, that network, is based on serial interface, specifically RS-45. And it worked for a long time. And a very sophisticated ecosystem of building management systems, Johnson Controls, Honeywell, to name a couple, grew a very, very powerful industry. But there are some shortcomings with not only wired technology, but also the 45 protocol, the 232 protocol. Any of these serial protocols have some pretty significant limitations. For one thing, they are not really scalable. For another thing, they're somewhat error prone. And because it's based on kind of a daisy chain, there's always a risk that if the wire is broken somewhere in the middle, some or all of the controls will stop working. Also, running wires in older buildings or complex installations or large facilities can be very time-consuming, very expensive, or prohibitive. If a building is on National Register of Historic Places or something like that, or has a particularly difficult construction material like stone, or prison might have very thick walls and a lot of rebar, it becomes very difficult to run cabling, or it becomes very unattractive. So wireless sensors, incorporating wireless sensors into a building management system really makes a lot of sense. Up to this point, a lot of the vendors of such systems have made wireless solutions that were proprietary. Doing things in a proprietary fashion is not the ideal. Open systems and open architectures allow you to have a much wider marketplace and results in much more innovation. There have been a number of wireless technologies in building management for a long time. Zigbee, Wi-Fi, Bluetooth, and Bluetooth Low Energy are also pretty common wireless technologies. And there's a company called Lumen Radio, which makes proprietary wireless radios. They have kind of an interesting ecosystem. Carriers have tried to get involved in this environment, deploying Cat-M and NB-IoT, but that, of course, involves paying somebody. And the upside of that, of course, is that you can pay a carrier to maintain the entire network and you just pay a monthly fee. But there are additional issues with that: security, performance, flexibility. So LoRaWAN really has filled a really nice niche, not just in sensor technology, but in the deployment and building management and also production automation. So let's talk about MultiTech and our LoRaWAN capabilities. We, of course, have a variety of LoRaWAN gateways, including the AP line, which is designed for interiors, carpeted environments, conduits, which are more rugged, meant to be installed in cabinets and more industrial situations. And then, of course, the IP67 base stations are meant for outdoor use on towers or on the side of buildings, something like that, where weatherproof is a requirement. And then all of those are equipped with LoRaWAN radios, and that allows them to connect to a variety of different sensors. And of course, we provide a wide variety of radio bridge sensors, including temperature, humidity, contact, leak detection, alerts, a variety of general purpose sensors that can be used and incorporated into the LoRaWAN gateways. But the great thing, of course, as I just mentioned about the LoRaWAN ecosystem, is that all sorts of manufacturers design LoRaWAN sensors. It's an open standard, and that allows for a very large marketplace of custom industry-specific sensors that can work in a LoRaWAN environment. And as you'll see in a few minutes, they're very easy to add to our systems using our mPower web interface into these gateways. You can easily add these devices and monitor their performance. Now, once you've established that connectivity between the sensors and the gateways, there's a lot of different places that data can go. It doesn't typically just stay in the gateway. You want to take those data points and put them somewhere else for analysis and trending and alarming and things like that. So we have what's called the mPower Cloud Connector, and this allows you to send those data points through a variety of different destinations, including MQTT, HTTP API, and Azure MQTT. So we give you a lot of flexibility in where that data winds up across different WAN infrastructure. So 4G, LTE, or LTE-M, or through Wi-Fi, or even through Ethernet. We have the ability to route that data to local resources or to distant resources across a WAN. And these are the places among many that you can send that data. MQTT, AWS IoT Core is a very popular destination, and we can provide secure connections to AWS IoT Core, Microsoft Azure, or as I said, HTTPS API endpoints. So great for custom development of applications. And then there's an additional ecosystem involving the Things network, Laureate, Senate, a whole range of places where this data can eventually wind up for further analysis and display. Now, when it comes to building management, it's kind of the same thing. We've got the gateways, we've got the sensors, but in this case, we have developed something called the Payload Manager. And this is where our BACnet configuration takes place. So we configure the general settings for BACnet. We determine which of these sensors will go into the BACnet system and what specific objects or data points are going to go into BACnet. Now, it's important to remember that it's not an either-or proposition. You can send data from these sensors to BACnet or to a different destination like MQTT or AWS IoT Core, or both. So in fact, some sensors could go to AWS or to Azure or to the Things network. Other sensors could go to BACnet, or they can both go the same direction. So we provide lots of different routing for these important data points. Now, typically in a building management system, because the gateway and the building management system are in the same general facility, they will typically go out over the local area network, and we can support that. But for more complicated environments, it's possible to use WAN to send this data. But typical installations include local area network. And of course, we support BACnet protocol, which will work with a lot of different organizations, products. Probably the most popular building management system is the Niagara environment from Tritium. And we work with that system, including the JACE controllers, as well as containerized versions of Niagara and server-based systems as well. Now, to test this environment out, you can also use something called Yabi, which is basically a test tool to see if you're getting BACnet traffic from the gateways and from the sensors. But to incorporate this fully into a building management system, you need something like Niagara to be able to really see its power and its capability. This is a typical building management system. And it's important to remember that these have been in place for a long time. So it's not like we're starting all over again. We see ourselves as more of an additive solution at this point. Right now, so many building management systems and sensors are controlled via the RS-45 and Modbus protocols. They connect in something like a Tritium JACE controller. But when we add our conduit gateway or our APs or our IP67 gateways via local area network to the JACE system, we can now add additional sensors into the environment. So you might have existing sensors here that are wired. Perhaps you need more. Perhaps you've only got one thermostat in a large building. You might need to have several so that you can more fully monitor and control the temperature. Maybe a boiler in the case of this situation. It'll tell you how hot the water is, but it won't tell you if there's a leak in that room. And so having a leak detector is important. Traditionally, when somebody's done in a room or warehouse, they turn the lights out with a switch. Perhaps it's better to have a proximity sensor so when people come and go, it can control the lighting. So we're adding additional information, perhaps preventative information, intelligence into an existing building management system. So we don't necessarily see these devices necessarily controlling things at this stage, although they can. But our initial view of this is that adding additional pieces of information to an existing building management system is going to go a long way toward helping people expand the capability and knowledge of what's going on within a building. So now that you've seen it work, how we attach the devices through Lens to the conduit gateway, through the BACnet payload manager, and then onto the BACnet environment, I'm going to take you through that one step at a time. We're going to add one device to the system just to show you how it works. And what we're going to do is we're going to take the keys from the push button that I have selected to add. We're going to add a new key. We're going to add a new device. We're going to give this a name. We're going to call this push button. We can spell correctly. CDC6. I've got an application network already. And a profile. This is US 915. And we're provisioning. Now to simulate this being a new push button, I'm going to pull the battery and re-add it. So it's as if we were adding this for the first time. Then I'm going to hit the button. I get a red LED response. And shortly I should see packets showing up and a join message. And there it is. The join has been granted. Now I'm going to go to the conduit gateway. I'm going to go to LoRaWAN under packets. I'm going to just see if, in fact, this device is showing up under the list of devices. And there it is right there. So I know CBC6 has joined. It's got a join request and acknowledgement. And now I can start sending messages from this device. So now that it's showing up in the conduit, I'm going to go over to Radio Bridge and add it there as well. I'm going to add device, MultiTech. We're going to call this push button CBC6. I happen to think that the naming convention, keeping them the same in all the different systems is critically important, especially when you start to add lots and lots of devices. And especially with BACnet, because you're not sure exactly what the device is for. That's why having something in the name having to do with its location, its purpose, something like that is critically important, especially when there's a lot of the same kind, whether it's contact sensors or temperature sensors or so forth. It becomes very hard to tell them apart once they're deployed. So having a consistent naming convention is extremely important. There's the app key, and this is a 301 single push button. I'm going to use that join UI, and I only have one gateway right now that's in Radio Bridge, so that's the one to choose. I'm going to confirm it. I'm going to view this device. And now I'm going to hit the button and try to get some information from it. But now the fresh data is starting to come in. I can tell by the yellow bands that the button is definitely being pushed and released. In terms of configuring this sensor, I'm going to have the supervisory period every 12 hours. I'm definitely going to use adaptive data rate, confirm messages. I want to know that this device is getting its buttons. I want to have not only uplinks but downlinks. So I want to enable the button to send a message when it's pressed, when it's released, and when it's held for more than 3 seconds. I also want the LED to illuminate and blink after send. So I want all of that information for the configuration of this button. I'm going to hit submit. And now it's queued up. And by either pulling the battery or hitting the button, I'm going to get new packets coming in showing that the device is communicating and will be uploading its configuration to the button here very shortly. So now that I see the packets are showing up in the gateway, I can go to the payload manager and add this sensor to the list of sensors that I'm using to send over to BACnet. And you can see that I've got a whole bunch of sensors in here already, including some movement sensors, connectors, or I've got some movement sensors. I've got some dry contact sensors and some temperature sensors as well. I'm going to add the button sensor to this list. So we click Add Sensor. It's a LoRa device. Now, unfortunately, we don't see the name of the device. We don't have a particular friendly name here. All we have is the EUI, but I'm going to use that because I know what it is, CBC6. And this is manufactured by Radio Bridge. We offer decoders for other kinds of LoRaWAN sensors, but we'll focus on Radio Bridge right now. Now, this is a 304 button. I don't see that in the list here, but it's pretty easy to add that. Again, this is beyond the scope of this particular presentation, but we'll use something very similar, which is a 3011, and hit finish, hit save and apply. And now what happens here is that this sensor and specifically the objects that I've created are going to flow out on port 47808 by default and broadcast to the Tritium Niagara network, specifically the Jace controller. So now that I've got it in lens, showing up in the conduit and in Radio Bridge, I'm going to now add it to the BACnet system. Okay, Workbench is open. I'm going to open up the host. I'm going to open up the device in which the Workbench and Niagara are located, which is a Jace 8000. So open up platform. And I'm going to open up the station as well. Now, these concepts are quite a bit beyond what we're talking about today, so I'm not going to go into too much detail about Niagara and how you configure it in order to become even vaguely okay with this product. Requires a week-long training course, which I haven't taken. I've gotten a few hours here and there from our friends at Tritium, but I've basically learned enough to become somewhat dangerous. So here we go in our dangerous efforts here. We're going to go down, dive into the BACnet network. We're going to choose MultiTech. And I know that that device is broadcasting because if I go to BACnet, MultiTech, Niagara Workbench, our BACnet environment, and we go out and discover all of the BACnet objects that we have been sending from the conduit, you'll see that it appears here. So I'm going to add it to my existing list. And this is the database of all of those BACnet objects, those sensor data points. I'm going to need more from that doorbell. In fact, I might as well go back and add something more than just the battery. So I'm going to add, again, from that same CBC6 push button, a button event. That means something's happened. I push the button and I should get an event indicator. We'll call this 701 PBCBC6 press. I should give it a more definitive description, but for now, we'll leave it like that. But in production, you want to make sure you have a very good naming convention. All right, back to our BACnet system. We're going to rediscover all of those points, and we should see doorbell button event function. And there it is. And by hitting the button, that should turn that to a 1, indicating that the button has been pressed. And there it goes. So 0 means hasn't been pressed, 1 means it has been pressed, and you can also send additional, more specific data about how long it's been pressed and so forth. But the whole point here is that I can send an alarm or some kind of message or indicator that this particular event has taken place. And in fact, let's do that. Let's go to our points. East doorbell. I'm going to create an alarm for this. This is going a little bit beyond what we normally would do here, but it just goes to show you how powerful this is. And we're a part of this whole ecosystem of BACnet objects and sensors and valuable data. I'm going to create what's called an out of range alarm. So we can create what's called an off normal alarm. So the message that I want to send out when this happens is doorbell pressed. Save that. I'm going to go back to my points. You see that it's already 1. Another example. This is a dry contact sensor with a switch on it. And all I'm doing is flipping the switch. And I also push one of these movement detectors as well. There's another one. So watch this west door open as I turn the switch. I go from 1 to 0. And it's blue, but when I open it again, it'll turn to 1. And because it's above 0.9, that means it's an alarm. It's an alarm state. Okay. So you can imagine the things you can do with these alarms. You can indicate a particular situation, a movement sensor, for example, temperature change, humidity. So now that I've shown you the list of BACnet objects and how you can set alarms for those, I'm going to kind of show that in action here. It's interesting to look at the list, but it's far better to have maybe a dashboard or some kind of visual that gives you an idea of what the devices are doing, sensors are doing. And so in Niagara, you can create different kinds of dashboards with those data points and look at them in kind of a textual fashion. I'll show you more of a graphical representation in a minute. But here we have a list of devices, and you notice that the water or the temperature sensors are below the alarm. That's because I stuck the leads in some ice water. So we'll take them out of the water and heat them up and see that the temperatures will go back to normal because my alarm is between 10 and 25 Celsius. You can see they've gone above the low alarm threshold, and now they're operating in normal temperature range. If I turn up the 4 to 20 milliamp sensor beyond 10 milliamps, that will report an error condition as well. And below here is a list of the alarms. So you see it's gone up, and I can go up here and look at that alarm a little bit more closer. So here's the text that I created for each alarm. So you have some idea of what exactly the problem is, and you can fill that in not only with what the problem is, but maybe what the action is. Call this individual or take some other kind of action. Here's a movement detector. Rather than having a textual representation of that, I'm going to have a kind of a green and yellow indicating when there's been movement. So right now there hasn't been any movement. I'm going to shake that, and you can see now it's turned yellow, indicating that something's going on in that area. Maybe something fell, or somebody's wandering around in there. It doesn't last too long, which it should be for a movement sensor. You want to indicate when it's stopped and when it's moving. So by shaking it, I can have it vacillate between still and movement indications. So throughout all this, of course, there are battery levels to make sure that the batteries are at the right level. And if they fall below those 3-volt levels, an alarm can go out saying you should address that issue with the battery. Now here's another graphic, and this one is more in keeping with the building management system. We've got a small floor plan here with the temperature sensor shown in more of a graphical fashion. Again, if I adjust my 4 to 20 milliamp sensor, it'll bring it back into range. The other thing I can do here is show the movement sensor, and indicates that in the area we're seeing some movement going on, just represented by the yellow flashing. I can also open the door or close the switch on the contact sensor, and you'll see that I put a yellow alarm by the doorway here, and now that's going to flash. This is going to flash continuously as long as that switch is thrown, indicating the door's open. And of course, we do have dedicated contact sensors for doors. This is more of a standard dry contact sensor, but it does the same thing. Opening the switch will return that to normal. Shaking the movement sensor will indicate that there's movement inside. So there's a lot of different ways you can display these alarms, but the whole point here is that these wireless sensors can add a lot of value to an existing building management system. Most building management systems may only contain temperature sensors, pressure, air quality, and those are all very important. But if you want to add additional monitoring capability, rather than having to go through the whole wiring process, you can simply deploy these sensors wirelessly and put them just about anywhere and gather more data. And then based on that data, have the building management system take some sort of action. So I hope you found that beneficial and helpful. We went through it very quickly, and particularly when it comes to the BACnet side of things, it can seem a little daunting because there's so much control, so many things you can do with a BACnet system, particularly Tritium Niagara. But hopefully gave you a flavor of what the capabilities of our products are, the sensors, the conduit gateways, and the integration with BACnet. If you have any additional questions, please feel free to contact your sales representative or partner representative, or you can reach out to me directly at the email address below. Thanks for watching.